Hey everyone. So as promised, I wanted to go ahead and create this video to go over the 6 questions that were on that sample question spreadsheet for part 2. Okay, so I'll go through these one by one, starting with question 1. Okay, so question 1 was about queue systems and basically determining if you're given information like this, when should you place an order in this last column here. Okay. So for this type of question, you're interested in knowing on any given day, what's the inventory position, meaning how much inventory did they have in the warehouse as well as in transit. Okay. And then I'm also interested in how much inventory did we exclusively have in the warehouse. Okay. And I also need to know if we have any scheduled receipts, which could be trucks that are inbound. And I also need to know if there are any back ordered items, which are basically customer who placed orders, and those orders could not be satisfied within a given day. So they're orders that are pending satisfaction, possibly on the very next day or whenever it is that a truck pulls up with inventory. Okay. So the question read, a distribution center stocks plasma TVs. The center receives inventory from a mega warehouse in Kansas with a lead time of 5 days. The distribution center uses a reorder point of 320 and a fixed order quantity of 280. Okay, so our reorder point is 320, and we have a fixed order quantity, which is the amount that we're going to place a purchase order for, of 280. Okay, and we're told the lead time is 5 days. So it'll take us 5 days to get inventory from the time we place the order to when the truck pulls up with inventory. Okay. Inventory at the end of day 1 is 440. That's already provided to you there. There are no scheduled receipts and no back orders. All demand and receipts occur at the end of the day. Okay. Determine when to use a queue system. All right. So as I mentioned in class, I usually start off by looking at what's the inventory position for any given day. Okay. And our inventory position for day 1 is accumulation of what is the on-hand inventory in the warehouse plus any scheduled receipts minus any back ordered items. Okay. So for day 1, there's no scheduled receipts and there are no back orders. So inventory position is going to equal our on-hand inventory. Okay. And I'll repeat that over and over for each and every day, basically just looking to see at the end of the day, how much inventory do we have in the system? And since the formula that I used here stays the same, which is our inventory position formula, which is a function of the on-hand inventory plus our scheduled receipts minus our back-ordered items. This formula that I have here stays the same, so I will drag it all the way to the bottom. There's no need to be doing it each and every time when you can just do it one time and drag your formula all the way down. Okay. Now the next thing that I will do is to calculate my on-hand inventory. Okay. And my on-hand inventory is a function of, as I mentioned, our on-hand inventory the previous day minus our demand that was satisfied. Basically, what did the customers buy on the present day? And then I will subtract any back orders from the previous day. Okay. So with that in mind, my formula here is going to look something like this. It's going to equal the previous day's on-hand inventory. How much did we have in the warehouse the previous evening? And how much did we sell? Let me subtract what we sold on day 2. And I will also subtract any back orders. Okay. And here, there was no back orders. So basically our inventory went down by 60 to 380. Let me drag this formula down all the way to the bottom as well. Okay. So now I'm going to use these 2 columns here to try and figure out when should we place inventory? When should we place an order for new inventory? Okay. And I'm going to go off of this reorder point. Whenever we drop down to 320 units of inventory or less, we need to place an order, and we're going to be placing an order for 280 units of inventory. Okay, so with that in mind, I have to go down and check my inventory position. Okay, where do we first of all drop to? Either 320 or less. That's going to be right here on day 3. And because we drop below 320, we need to place an order for 280 units of inventory. Okay, and it's going to take us 5 days to get that product in. So if we place it on day 3, 3 plus 5 is 8. So we expect to receive it on day 8. Okay, but in the meantime, between day 3 and day 8, this becomes a scheduled receipt. So we add it to the scheduled receipt column and say that we have something in transit, and the amount we have in transit is 280 televisions. But on day 8, I don't include it here. I move it over to this column here, because over here it becomes an actual receipt. Somebody receives the product into the warehouse. So I'm going to add that inventory into our on-hand inventory. Okay. Then I go back to our inventory position column and again look for a reorder point of 320. And we drop down to 315 on day 7. So I know here again I need to place an order. And the order is going to be placed for 280 units. And as soon as I do that, it becomes a scheduled receipt for the next few days, right? 280, 280, 280, 280. And since we place this order on day 7, 7 plus 5 days of lead time means we're going to receive it here on day 12. Okay. So on day 12, a truck pulls up with inventory and we go ahead and receive the 280 units of inventory, and our inventory stock goes up, our on-hand goes up. Okay. Come back to our inventory position column and again look to see when do we drop below 320. And I see 320 here on day 13. Okay. And that triggers another purchase order. And we place a purchase order for 280. And as soon as we do that, that becomes our scheduled receipt. Okay. So that completes this question. You've completed every single on-hand inventory calculation, every single scheduled receipt. In this example, there are no back orders. And we've calculated our inventory position. So to answer the question, we basically ordered 3 times. We ordered inventory here. We ordered inventory on day 7, and we ordered inventory on day 13. Okay. So that's what we call our queue or continuous system. Okay. All right, let's move on to question 2. And question 2 is a variant of the queue system. With the queue system, keep in mind that we order whenever we drop down to 320. So it could be the very next day after we ordered this. If we had dropped down to 320 here, I would have placed another order here. There's no specific day for placing an order. We just look at what's our reorder point. Do we have enough inventory? If not, we go ahead and place an order. Okay. Now, question 2 asks you to repeat the same, but in this case here, we're going to look at the P system. And P system, P here stands for periodic review system. Okay. And your typical periodic review system will have a specific buy night where the system is going to go ahead and place an order on a specific day of the week, say, for example, every Thursday, or every 5 days, or every 6 days. Okay. And in between those order or buy nights, there will be no purchasing done, regardless of what happened, unless there's an expedite request where we need to place an emergency order. We typically, with the P system, wait for that buy night. Okay. So with this question here, we're told, again, the lead time is 5 days. We're told something here called the first review. The first review is scheduled for the end of day 2. So that's going to be the first time that we're going to be checking the system to see whether we have enough inventory. So I'm going to put that our first review here is going to be on day 2. Okay. What else are we told? All demand and receipts occur at the end of the day. Lead time is 5 days. So lead time, like the previous example, is 5 days here. And management has set target inventory level to 620, 620. Okay, so that means that anytime we go to review our inventory, we want to try and bring back our inventory up to 620 units. Okay, and our buy nights have a period length of 6 days. So we'll be placing orders every 6 days. Okay, now with regards to Q, if you look at the first example, our Q was 280. We ordered 280 units every single time. Here, we're just going to order as much as is needed to get us back to our target inventory level T. Okay, so we're just going to order as much as we need. Okay, so let's go ahead and try and put together this table. And I'm going to again start with my inventory position column. Okay, and my inventory position formula here was equal to our on hand plus scheduled receipts minus your back orders. Okay, and I'm going to drag that all the way to the bottom. All right, I needed to copy this column here over because we're using the same data. Our demand data here is missing. Okay, so after I'm done with putting in our inventory position calculation, I need to know how much inventory did we have on hand at the end of the day. So just like we did in the first example, our on hand is going to equal our on hand for the previous day minus the number of televisions sold minus any back orders that we may have. Okay, so that formula looks like that. Our on hand for the previous day minus the TVs demanded for this, the current day minus any back orders for the previous day. Okay, so I can drag this all the way down. And now I'll go to our ordering column where we have our Q here. Okay, and we're told that our first buy night, our first review is on day 2. So I have to keep this in mind because this is going to determine how frequently we're going to be placing purchase orders, right? So every 6 days, we're going to be placing an order starting on day 2. Our next buy night is going to be on day 2 plus 6, which is day 8. And then 6 days later will be 8 plus 6. So we're going to again purchase stuff on day 14. Okay. So in between here, there's no buying. There's no, let me just darken this out. We're not going to be placing any orders here. Not placing any orders here in between. And no orders on day 1. Okay. So we're only going to be focused on how much do we buy on day 2, day 8, and day 14. Okay. Now keep in mind that as you're doing this calculation, it's going to be a function of whatever your Q value here will be a function of your target inventory level minus your inventory position. Okay. So our target inventory was 620 from the information provided in the question, minus your inventory position on day 2, which is 380. So we are placing an order for 240 units. Okay. Lead time from the supplier here is 5 days. So I know we're going to be having scheduled receipts of 240 for the next 4 days. 240 to be received on day 7. So I'm going to add that 240 to the warehouse inventory, 240. Okay. Then I move on to our next buy night, which is right over here on day 8. Repeat the same calculation. One moment. Okay, so I'm hoping that there's a bit of a glitch on my end here. But for day 8, this is going to equal our target inventory amount of 620 minus 225. So we're going to place an order for 395 televisions. And that becomes a scheduled receipt, 395, 395, 395, 395. And since we placed an order on day 8, 8 plus 5 is 13. And we're going to receive on here 395 televisions on day 13. Okay. Then we move on to our last buy night, which is day 14. And here again, it's going to be our target inventory value minus your inventory position. Okay. So our last part of that is that we're going to place an order for 275 units of inventory. And this completes the entire table. We're not going beyond day 14, so we're done. This is all I need to see. Okay. If you're answering this question, this is what I'm interested in seeing. I don't need to see any of these. You can have it on or you can leave it off. That's fine. But I want to see a completed table. All right, let's move on to question 3. Now we're back to forecasting. Okay, so this question here reads, James and Maddie work for Statesboro Toolworks. The boss tells them that she'll promote the person who has the best forecast for the firm's electric tool. Jenny emailed them the demand data. So this is the actual demand data here. And then she asked them to place a forecast, okay? The table below shows actual demand, and then it shows James's forecast and Maddie's forecast. Calculate which of the two has the more accurate forecast. Who gets the promotion, okay? Now, with a question such as this, you can either use the mean absolute deviation, or you can use the mean absolute percentage error, or you can use a mean squared error, or you can use a standard deviation approach. Okay, there are many ways to build this cat. Okay, I typically prefer to use the MAD approach, but you could use any one of these approaches. Okay, so let's go ahead and compare these two guys' forecast. Okay, and what I'm going to do is I'm going to separate the two so that I'm dealing with one at a time. Let me copy and paste this. Okay, so in the first example, I'm going to be dealing with James. And in the second example, I'm going to be dealing with Maddie. Okay, we're interested in comparing the two. So let me start with James. And then to make my life easier, I want to do exactly what I did for James to Maddie's data. Okay, so that way I can possibly copy and paste, so I'm not repeating this over twice. Okay, I always want to start off by calculating my forecast error. Okay, and your forecast error is the difference between your demand and your forecast. Okay, so your actual demand is here, and my forecast is given to me in column C. So the difference between these two is 102 minus 97. I get a 5. Okay. So now I have my forecast error, and I could do the same. I could copy this column over because it has a formula. Let's copy it over and get Maddie's forecast error as well. Okay. Now, if I was to use a mean absolute deviation approach, I would need to have a column here with my absolute deviations. Okay, and your absolute deviation column here, give me a moment. Is just basically getting rid of any negative values here. You'll notice here that everything is positive. So I really would just type them all in, but I'm just going to, for consistency's sake, because I have to do the same for Maddie, and I see Maddie has some negatives here, I'm just going to repeat, I'm going to do the same steps that I would have done if they both had some negative values, okay? So let's start with James. Okay, so for James, his absolute value, which is the same as the numbers here, it's going to be 5, 3, 5, 6, 6, 6, 6, a whole bunch of numbers there. Okay, and I'll repeat this with Maddie. Get her absolute deviation values, get rid of those negatives, replace them with positive values. And at the bottom, I'll get my mean of the absolute deviations, which is your mean absolute deviation. So the MAD is the average. Average is the same as mean of this information. Okay, so I have a 5.6, and I can repeat the same with Maddie's data. And here again, I'll calculate the average. And I get a 10.7. Okay, so this is James's MAD, and this is Maddie's MAD. Okay, and as we mentioned with the measures of forecast error, the smaller the measure of forecast error, the better the forecast. So just looking at the mean absolute deviation, James has a much better forecast than Maddie. Okay, if for whatever reason the question asks you to maybe calculate using the MAPE, then I would need to add a column here and call it my absolute percentage error. Okay, and this column here will require me to calculate the mean of the absolute percentage errors. Okay, so the first thing I need to do is figure out what's the absolute percentage error. Let me just do something real quick here. Okay, so for the absolute percentage error, I would get the absolute error divided by the actual demand. Okay, and that gives me some percentage if you click on the percentage sign here. And I could drag this all the way to the bottom and then calculate my average, because we're looking for the mean of the absolute percentage error. Okay, and that gives me a 3.8%. I can copy this over and do the same on this end here. And now we see that Maddie's forecast is off by 7%, while James's forecast is off by 3.8%. So with both approaches, we can say that the person getting this promotion is going to be James. And I think that should be the last part to this question. All right, let's move on to question 4. So question 4 is about forecasting using regression, and this has to do with the regression line. Okay, the Agricultural Extension Agent's Office has tracked fertilizer application and crop yields for a variety of chickpea and has recorded the data in the table below. Okay, so here we have the cumulative forecast error, which is your measure of bias. You have the mean absolute deviation at 28.6, the mean squared error, the standard deviation or the standard error, mean absolute percentage error. Okay, so with all that information, you're also given some information down here on the regression line, which is basically your equation of the line, your y equals to mx plus b, right? So here you need to know your slope, you need to know your y-intercept. That's provided to you in this section here, okay? So I'll just, let me run this off here. So you have this information right here. This information that you're looking at here is your regression equation information, okay? So the question here says, use the information provided in the table. The value of fertilizer required to generate 100 bushels yield is how much? Okay. So in this case here, our y, which is our yield, our y is our dependent variable. So we can write this formulation down as follows. So 100 equals, what's our slope? I'd have to go here, and I see that our slope here from this formulation is 8.5. So 100 equals to 8.5x plus our y-intercept is 8. Okay, and so this becomes a matter of solving for x. Okay, so since I want to solve for x, we can simplify this equation and say this equals to 100 minus 8. And I'm going to divide that by 8.5. Okay. And if you do the math on this, you get your value of X. Okay. So X equals 10.84. So the amount of fertilizer that this farmer needs to put on his field is 10.8, or you could round it up to bags. Okay. So this type of question might involve you solving for X. It might ask you to try and figure out what's the meaning of this correlation coefficient. What's the meaning of the coefficient of determination? Please read up on that. Where is your measure of forecast of bias? Please read up on that as well. What's the next question? Use the information provided in the table. What percentage in the variation of the variable bushels is explained by the value of the variable fertilizer? Okay, so we have these two here, bushels and fertilizer. Okay, and we're trying to assess whether or not there's a relationship between these two, and if there does exist a relationship, how can we use our understanding of that relationship to determine causation, or how much of the variation that we see in yield is explained by how much fertilizer is used. Okay, so that requires you to know that this question is asking you for the coefficient of determination. Okay, and that's already given to us here as 79%. Okay, so 79% of the variation in bushels is explained by the amount of fertilizer that the farmer uses. Okay. All right, so for this type of question, just make sure you understand this output here, because it could come in many different variations. All right. Question 5. Question 5 is one about ABC analysis. And this question says, Jarvis Hardware has the following inventory information for its warehouse. From the table above, which statement below is most accurate with regards to an ABC analysis? So I require you here to actually conduct a full ABC analysis of the data, okay? And it typically revolves around what's the total dollar value of these items and what's the percentage of SKUs represented by these items, okay? So the total dollar value, let's add a column here, total dollar value of each and every one of these. Wait to add one space down here. Is just what's the per unit cost multiplied by the number of units in inventory. So this is $96 multiplied by 24. And that gives us 2,314. So I'll drag this all the way to the bottom, get the total value of our inventory, but I'm also going to also sum this up. Let me figure out what the sum total here is. So the sum total of all this is $81,827, okay? And now one thing that I need to do, I would like, just for simplicity, to sort my data on the basis of this column here, okay? So I want to sort and have the largest value, which I think is G, $52,540, be at the top. So let me go ahead and highlight all my data and sort. I'll do a custom sort, and I'm going to sort by total dollar value, largest to smallest. Okay. So with that in mind, I can now put my total dollar percentages. Okay. So I want to figure out what percent of total inventory does this account for. So here I am going to take whatever value I have here, divide it by the sum total at the bottom, starting with product G. So this is 52,540.2 divided by the total, which is 81,827.83. Okay, and this is supposed to be a percentage, so I'll change it to a percentage. 64%, drag it all the way down. Okay. And the next thing that I need to know is what's my total SKU percentage. So I have here a total of approximately, these are 7 different items. For my total SKUs here, I'm going to just have every line item be 1 divided by 7 because we have a total of 7. And I'm going to change this into a percentage. Okay. So now I can put my classes. This is where I try and figure out what's my A, what's my B, what's my C. Okay. And your typical classes, starting with A, class A of inventory accounts for the smallest number of SKUs, but the largest amount of dollar value items. Okay. So, and typically it follows kind of like the Pareto principle, 20% of SKUs approximately with around 80% of value. Okay. And as I look at this here, product G is obviously an A item. It accounts for 64% of the total value. So I am going to put this and call this product A. And sometimes you might say, let me get to this 80%, but the idea is not really to get to 80% because that's just a guideline, okay? I might want to look at the value of the next item and see, is this the value of this product here at or near the value of G? That's a pretty big drop in value. So I wouldn't necessarily want to include G and E in the same bracket because G's value is exceedingly high. E's value is not that high, but I could potentially combine E, D, and B, because if you look down here, the sum combined total dollar value is around 30%. So 12% plus 9% plus 8%, we get to approximately 30% of value. And if you look at the total SKU percentage down here, that's 43%. So I'm going to put these as my B category. Okay. And then the last ones here, if I add them up, adds up to approximately 6% of value. But in terms of SKU count, that's approximately 43% of SKUs. And so I'm going to put this as my C inventory. And that would complete these, the table that needs to be completed here. Okay. Now, with regards to the answer to this question, which statement below is most accurate? Items F and G should be the same category. F and G, nope, those are different categories. B and E should be in the same category. B and E. Yes, those are in the same category. So this should be the correct solution. C says G and A. G and A are not in the same category. And then D says B and C. B and C are not in the same category. Okay. So that's your ABC analysis. You end up with a table that looks something like this, where you can segregate them and have your A, B, and C in different categories here. Okay. As you're doing this, go back to the textbook, go back to the PowerPoint, figure out what are the percentages for A, figure out what the percentages for B, and what are the percentages for C. Okay. That'll be a guideline. You shouldn't expect it to be exactly what it is in the textbook, because again, inventory is a fluid. It's never going to be exactly 80-20. It's going to be some variation of that, but it'll be up to you to make your best judgment of what would entail, what items should be in A, what items should be B, what items should be C. Okay. All right, we're down to the last question, question 6. 10 months of data. This is a forecasting question. 10 months of data and the forecast for those same periods that are in the table below. Use the bias, the mean absolute deviation, and MAPE to analyze the accuracy of the forecast. Okay. All right. So again, whenever you get a forecasting question, you might want to start off by calculating what's a forecast error. Always start with the forecast error column. Even if you don't know what to do, just make sure to include this column here. If you don't have a forecast error column here, it kind of would tell me that you don't know what you're supposed to be doing with the question. Okay. So I always want to find out the difference between what is the actual demand and the forecast. And in this case, for January, the difference is 42 minus 37. And I'll do the same for each and every month. Okay. So that gets us our forecast error. Now, to answer the first question on bias, our mean bias, okay? Our mean bias. Bias is calculated using two specific calculation. One is your cumulative sum of forecast errors, or CFE, or the average forecast error, AFE, okay? This question says use the mean bias, use the average forecast error. So we already have all the forecast errors here. So our average forecast error is just going to be the average of this column. Okay, so average forecast error is approximately 7.25, and that would answer the first part of this. If this question had asked you to calculate the cumulative forecast error, CFE, then you'd have just summed them up. Sum up all the errors that you have here. Okay, and our CFE is 72.5. Okay, so the question is asking for your mean bias. That means you're looking for the average forecast error. Okay, and the numbers here are positive. So the bias, the fact that the number is positive means that this whoever put this forecast in place tends to under forecast actual demand, right? So the numbers tend to be, when the customers buy, it's typically higher than the actual forecast. The forecast was 50 here, customers bought 58. On March, it was okay. When you get to April, you find that the forecast was below the actual demand. The same for almost every month here. Okay, so that answers the first question. The next one was calculate the mean absolute deviation. Okay, so the mean absolute deviation, I need my absolute data. And as I look at these numbers here, I do not see any negatives. Okay, so in this specific instance here, my mean absolute deviation will be the same as my average forecast error. Okay, because remember, for the mean absolute deviation, I require that you calculate another column called the AB absolute deviation. And you'd use the absolute function here, but all these numbers here are positive. So this was a weighted step. You'd have only needed to do this if you actually had negative values. Okay. In this case here, there are no negative values at all, but we can still do it step by step. This is perfectly fine. Okay. And once I've got my absolute deviations, I'll get the mean, which is the average of these absolute deviations. And again, you find here it's 7.25. Okay, so this here is your MAD. Okay, and the very last question is asking you to calculate the MAPE. So I need my absolute percentage error. Okay, and your absolute percentage error is a function of your absolute deviation and the actual demand, right? So I'm going to divide the absolute deviation by the actual demand, okay? And typically I like seeing these as percentages. So here for January, the forecast was off by approximately almost 12%. For February, the forecast was off by almost 14%. In March, the forecast was right on point, so there's no deviation. And I'll do that for each and every month. Okay. And once you've done that, the last step will be to just get the average of this column. Equal average. Okay. So my absolute mean absolute percentage error is 7.7%, and that would complete this question here. All right, hope this helps. Please take time to go to the back of the chapters, see if there are any other questions at the back of the chapters that you can use as test material. Try and see if you can work through them before you have your part 2 of this test. Okay, thanks. I'll stop here.